Welcome to the CANape Quick Start. In this video, we'll be talking about how to use data mining with CANape. First, let's talk about the inspiration for data mining. When you run a measurement, you get a resulting measurement file in CANape. You can see here on the left that my throttle position is a hard acceleration, let off the throttle, hard acceleration again. So let's say I call this measurement file busy driver 32825 and so on. This is today's date. Now let's say I run a second measurement. This is also today's date, different timestamp. I have another measurement. Let's say I have different conditions under this test case. The more I run my measurements, the more resulting measurement files I get. Now, you see, the more measurement files you have, the more difficult it is to find what you're looking for. So let's say I have a specific test case and I want to find where the resulting signal value is within a certain bound. How do I find this when I have so many measurement files? It can be hard to remember exactly which test run was the one you're looking for. So how do I find this? Well, the answer is to use data mining with CANape. Data mining allows you to input a condition, apply that condition to an entire folder full of your measurement files, and return which files meet your signal conditions. We're going to begin this demo with the Comprehensive Vehicle Demo example project in CANape. To perform data mining, we first must load a measurement file. To do so, I can navigate to the Symbol Explorer and find the Measurements tab. When I right-click, you'll see a couple different options. The one I want to click is Load Measurement File. File Explorer will then open up in my project directory. As you can see here, I have a couple different folders, but the one I'll want to select is the one titled Measurements. My Measurements folder has all of my recordings, but for simplicity's sake, I'm just going to select the first one. CANape is now asking if I want to handle all recorders as an individual measurement, all files from the same recorder as an individual measurement, or all individual files separately. I'm going to choose all files individually because I want to illustrate something with data mining later in this video. The Symbol Explorer now shows that my measurement file has loaded. However, there's still nothing populating in the graphic window. I want to now show my measurement file in the graphic window. To do so, I'll go back to my measurement file in the Symbol Explorer. When I right-click the measurement file, a pop-up window will appear. I want to click the button that says Show Values from Measurement File. Selecting the button called Show Values from Measurement File allows you to see the measurement file values in the graphic window. When I click on the graphic window, I can press the F key to fit the measurement to the scaling of the window. We've now completed all the preparatory steps to get ready for data mining. To open up the data mining editor, navigate to the Analysis tab on the ribbon. Here, you'll find a button that says Data Mining Editor, and this will open up the data mining editor in a new tab. In the Configuration section, there's a file filter list, which is where you define the files that you want to operate on. There's Methods, which is where you define what data mining you plan to do. Analysis Profiles, which is where you can define specific signals to operate on, and Options with some advanced data mining features. Right-click in the file filter list and select New to specify which files to operate on. The drop-down on the right of this ribbon will allow me to select the directory that my measurement files are located in. When I select my directory, I can now change my measurement file flag. Let's say I want to search for all of my files called busydriver_ with the date. I'll change my wildcard so it says busydriver_**mf4 and it will search for all appropriate files. Every file in my measurements directory corresponds with this name. As you can see in the Symbol Explorer, my file is called busydriver_ with the date, so this file will be included. Now I can specify a method. This will allow me to tell CANape what actions to perform on the files I want to search for. If you recall from our Castle Quick Start video, we have functions and scripts, but we also have a third category called algebraic conditions. This is what I'll be using for our data mining video today. The algebraic condition window has a big text field that says definition. This is where you'll specify the logic for your data mining. Below it has a bunch of miscellaneous features. There's a signal selection button as well as decimal numbers, hexadecimal numbers, mathematical operations, logical operations, and bitwise operations. The second column has trigonometric functions, logarithmic functions, and then advanced signal analysis. When I select a signal, data mining requires a signal from a loaded measurement file, so I'm going to choose File 1. This is because data mining operates only on measured files, not unmeasured device signals. Pressing OK opens up the signal selection window. In my data mining example, I'm using the comprehensive vehicle demo, so I want to use the vehicle speed signal from the simulator. I want to use the file1.busydriver vehicle speed signal to see every time the value exceeds 100 kilometers per hour. I'll use the greater than or equal to logical operator, and then just type in 100. Note that you don't need proper Castle syntax, such as a terminating semicolon in the algebraic condition value. I can still use the syntax test button to make sure my code will run. When I press it, I can see it compiles, and now I'm ready to run my data mining example. The lightning bolt on the ribbon starts the data mining analysis, but there's also a save icon to the left. This allows you to save your configuration in this section below called Saved Configurations. Now let's run it. After I press the lightning bolt, it'll take a second, but on the bottom left hand you'll see a section called Results. Analysis with today's date.dmr now appears. The data mining results file will have all the hits from your data mining, all the files scanned, and the configuration you used for that result. Back in the main project area, the data mining results show up here in the Symbol Explorer as well. We'll use this section to visualize everything. I can drop down the resulting DMR file for a more comprehensive view. I can see two categories called All Hits and the 3 measurement files that the hits were found in. If I expand the hits, I can see all 3 of them. I simply double-clicked hit 1, and now my graphic window shows me the resulting location that hit was found at. When I move the measurement cursor, I can see all of the metadata associated with the hit. This is all recorded into the DMR file, so this can be seen there as well. I'd also like to point out that all 3 of these hits are from different measurement files. Pay close attention to what happens when I double-click hit 2. Notice how my measurement ends with 0.6. When I go back and double-click on hit 2, it will automatically replace the measurement file that's loaded. Now, the measurement containing hit 2 ends with 2.2. I can move the measurement cursor and again take a look at all the metadata associated with hit 2. I'll double-click on hit 3 to analyze my last data mining result. My measurement file will once again be replaced with this hit file. With each hit, I can move my measurement cursor around. This helps you analyze the behavior surrounding the event that you wanted to find a data mining result for.